drawing graphs because so many graphs are there. I'll try to complete this within this session itself. Some basic graphs. What you have to know? You have to know how will be y is equal to x square. You should know how to draw mod x, ln x, x cube, e power x, sin x. Okay, enough. These are the basic graphs you are supposed to know. And also y is equal to if x square minus 4x plus 3 is there. Okay, this is a quadratic actually. You should know how to draw the graph of this one also. Immediately. All these graphs must be drawn instantaneously without thinking, without taking scale and everything. You at least know the structure of each and every function here. And of course here the factors are x minus 3, x minus 1, and this is important for us. These factors are important. Now look at each and every diagram. I take this as first, second, third, fourth, fifth, sixth, seventh. Okay. For the first one, y is equal to x square diagram will be like this. Up open parabola. And for the second one, y is equal to mod x graph will be like this. V having a vertex at origin, and y is equal to ln x. Here we have two cases. If I write a base a here, okay, log a, when a is greater than 1, the graph will be like this. This is when a greater than 1. And the graph will be like this when a lies between 0 and 1. When a lies between 0 and 1, ln x graph will be like that. Two cases in log. This is case A, case B. And in fourth, x cube. I so many times said your x cube graph will always look like this. Is it not? And e power x, e power minus infinity is 0, e power 0 is 1, and e power infinity is infinity, no? So it will go like this. That is e power x. And sin x, your favorite one, you know, at 0 it crosses maximum value 1, minimum value will be minus 1. It is a wave like this. That is y is equal to sin x. And the seventh one, which is a quadratic, x square coefficient is positive. Since x square coefficient is positive, it is up open parabola. And if this is origin, it is clear that when x is equal to 1 and x is equal to 3, the curve becomes 0. Y is equal to becomes 0 if x is equal to 1 or 3. Up open parabola with intersections at 1, 3 with x axis. 1, if I suppose this has 1 and this has 3, up open parabola with intersection with x axis 1, 3. Okay, and you have to find this one also. Where it is cutting y-axis means if I put x is equal to 0, x is equal to 0, minus 3 into minus 1 is plus 3 now, so this should be 0, 3. So at a distance of 3 units from origin on y-axis, it is cutting y-axis. So while drawing a parabola, you should be careful Actually whether it is up open or down open. First thing is that one, if x square coefficient is positive, up open. If x square coefficient is down open, find factors and see the intercepts on x-axis, and by putting x is equal to 0 you will get where it is going to cut y-axis. If these three things you understand, then easily you can draw the graph. Come on, these are the basic graphs. First of all, draw this. How to draw which type of graph? Here we'll see the categorization only. If you know the graph of the basic graph, and to that basic graph, if some additions or deletions are there, how to draw, that we are going to learn. And here the first one is when if y is equal to, you take any function, okay, plus or minus some a is there. Let us suppose in all these cases, let us suppose a to be positive because I already mentioned plus or minus. Okay, so a take as positive. Then what to do? When you see to a basic graph, if something is added or subtracted, then what change you have to do in the basic graph? Means shift the graph, right? Shift the graph. When you write plus a up, you shift the graph up. If we take minus a or down, by how much? By a units. By a units. That is how we have to draw a graph of this type. For example, I take y is equal to mod x, right? For this, if I take f of x is your mod x, if f of x is equal to mod x, from that you have to write mod x plus a once and mod x minus a also another time. So our intention is to draw this graph by the basic graph of this one. Just now I have drawn basic graphs. No, you remembered, I think, how this f of x is equal to mod x graph will be. This is your f of x is equal to mod x graph. If I take mod x plus a, what I said, we have to shift the graph. We have to shift the graph up. So the same graph, this is the graph now. You shift this up. By how many units? By a units. Whatever we are adding, that we have to shift. To that extent, we have to shift. Okay. If we subtract a, you shift the graph down by a units. I hope you understood. Now this is going to be your mod x plus a, and this is going to be your mod x minus a. So here it is, from here to here your distance is a units, and from here to here also distance is a units. You can take this as 0 comma a. This point will be 0 comma a, no? And this point will be 0 comma minus a. So dotted lines represent our new graph, and this is the basic graph. Remember, note down. Let us see y is equal to sin x, and from that sin x plus or minus 2 graph. You know how to draw sin x graph. Maximum value of sin x will be plus 1 and minimum value will be minus 1. because we require +2. I draw this little bit down, right? 0. Here we'll have pi by 2. Let me take up to pi this side also. Minus pi by 2 minus pi. Maximum value of sin x is +1 and minimum value will be -1. Now I'm drawing original sin x graph. Sin 0 is 0, sin pi by 2 is 1. So here it will come like this. And when it reaches pi, comes to 0. At minus pi by 2, sin is -1 and this one is minus pi. This is our complete one full cycle of sin x. Now this is y is equal to sin x. Now sin x +2 means, if we add, what is the condition here? For sin x, if I add something, the graph should shift towards up, shift up. So +2 means 0, no? From 0 to, what is the maximum value here? 1. So if I add 2, it will reach 3, no? 1 + 2 is 3. So I have to indicate 2 and 3 also, right? So now for the new graph, the maximum value should reach 3, right? And 0 goes to 2, because 0 + 2, 2, no? So same graph must occur between these two. Same type of graph must occur between 1 and 3. So you are going to do like this. Right? If you put sin 90 here, sin 90 is 1. 1 + 2 is 3. When I put x is equal to 90, y value should be 3. So sin 90 became 3. Like that. And similarly, -2 down you can draw like that. Okay? Take this. Now this is the graph of g of x is sin x +2. Don't take pen and pencil and maybe using scale. Drawing means it takes time. No need. You can draw a rough diagram. Now second one, if y is equal to f of x plus or minus a is there. In the first case, it is f of x. That is a separate thing, separate function. Function plus some constant is there in the first case. But here, for the domain itself, we are adding that constant or subtracting that constant. So in every classification, in every type, we do one is function plus some constant, and immediately to that x only, if we add that a, what happens, or subtract a, what happens. Like that, in every type we see function plus a and function of x plus a, f of x plus a or minus a. So when you see this x plus a or x minus a in the bracket itself like this, to x only we are adding. To x only if we add or subtract a, then how the graph is going to be? Shift the graph, okay? Shift the graph left or right. For the first sign, I wrote the first one. For the second sign, I wrote the next one. So when I write x plus, shift the graph left. If I take minus, shift the graph right by how many units? By whatever the number you write it here, by that many units, by a units. This is how we have to draw graph. Now let us take one example. Again, I take a simple example, y is equal to mod x. So if f of x, y is equal to f of x generally. F of x is mod x, and that is the basic graph. From that we want mod x plus mod of x plus say 2. I keep one only, okay? And one more function, mod of x minus 1 also. Plus or minus 1? If I take a as 1, x plus 1. If I take a as minus 1, x minus 1. But the basic graph is f of x is mod x only. Now look here. You know the basic graph is like this, mod x for this one. And for this one, y g of x is mod of x plus 1. What I said, if plus 1 comes, shift the graph towards left first, right? This is the basic graph first of all. This is the original graph. F of x is mod x. Now if I shift this towards the left by 1 unit, if this is 0, it will be minus 1. And towards right means here plus 1. So it is clear that shifting this graph towards the left means this vertex must come here. If we shift this graph towards the right, its vertex by 1 unit, its vertex should come here. And also, where it is intersecting y-axis, that is also important. If I put x is equal to 0, y is becoming 1. So when x is 0, suppose y is 1 here. Y is 1 here. Right? Now we are shifting this towards the left for this. So I draw dotted lines. Very parallel to this one only. This line must be parallel to this and this line must be parallel to this. And the most important things are where we are going to get vertex and where the graph is going to cut y-axis. By putting x is equal to 0, we can understand where it is cutting y-axis. So this is the graph of this one, x plus 1. I can write this is the graph of, okay, g of x is equal to mod of x plus 1. Now this one, h of x. H of x is mod x minus 1 means we have to shift the graph towards right. Again here if I put x 0, we are going to get y value, no? Y is mod of minus 1 is plus 1 only. So again it should pass through this one only. Like this. This is the graph of h of x is equal to mod of x minus 1. Right? So this is the original graph. And this is mod x plus 1, this side, shifting towards left. And mod x minus 1 means shifting towards the right by 1 unit. So each and every graph is in this. Copy down. I hope you are understanding. See once again, when y is equal to x square is the basic graph, through that we have drawn x plus 1 whole square and x minus 1 whole square. This is following this property. When x square is there, if I add to x1, it became x plus 1 whole square. Then we have to shift this graph towards the left by 1 unit. This is the original graph. I shifted this original graph towards the left by 1 unit. Actually, vertex is at 0. Now after shifting, vertex is at -1. Similarly, for x minus 1 whole square, when minus appears here, we have to shift the graph towards right by 1 unit because x minus 1 is there. So you shift the same graph towards right by 1 unit. Now let us move to third type. Y is equal to, if y is equal to minus of a function is there, means minus of x square. If you take this example, minus of x square, then what to do? Reflect the same diagram by x-axis. Reflect means take the reflection. Reflect f of x with respect to x-axis. Right? Take the reflection with respect to x-axis. So I am going to consider the same example. If y is equal to x square is this one, I want g of x as minus x square, because for this entire function just keep minus x square. If this is the original graph, take its reflection with respect to x-axis, its reflection will be like this. So this is f of x is equal to x square, original graph. When I keep minus, you have to take the reflection of the original graph with respect to x-axis. Now this is going to be g of x is equal to minus x square. Very simple. You take any example, but the thing is take reflection. Suppose if I take y is equal to e power x from this, if I want minus e power x, your basic graph y is equal to e power x will be like this. It's not. This is y is equal to e power x. I said you have to know basic graphs first, how to draw basic graphs. And take its reflection with respect to x-axis. So it should come like this. Dotted lines. Like this. This is your g of x. This is your g of x is equal to minus e power x. Now see type 4. Let us take one more example on this only, one big example. You have to be fast in drawing. Okay, take fast. One more example I take. Suppose y is equal to f of x is equal to, I take x square minus 4x plus 3. Whenever I want to draw a parabola or a quadratic, using a quadratic, I use this formula. I use this question. Okay, in almost all examples I use this, because directly we can take integers in order to make you understand well. Factors are directly integers. You can write x minus 3 into x minus 1 if you factorize. And in the place of x, I want minus, no? I want f of minus f of x. Now g of x will be minus of f of x. So this will become minus x square, and this is plus 4x only, minus of minus, and here we have minus 3. I want the graph of this one now. By using this, if you observe this is the up open parabola with intersection at 1 comma 3. At 1 comma 3, x intercepts are there, and if I put x is equal to 0, y intercept is 3. So somewhere here 3. So graph must be like this. This is the graph of y is equal to f of x. Okay. Right. Now what about this one? Whenever minus comes, what I said, to the entire graph, you have to take its reflection with respect to x-axis. So this will become like this, no? So take its reflection. If it is cutting at 3, its reflection must cut at minus 3. So it should come like this. This is your g of x is minus x square plus 4x minus 3. So keep dots, because always I am indicating the original required graph by dots, dotted lines. Now fourth type 4. Here in this case I kept minus inside, no? Now if a function y is equal to f of x is become minus f of minus x. In the previous case I kept this minus outside, but now for x only, if I keep minus x, then the procedure is reflect about y-axis. Reflect about y-axis. When minus comes for the function itself, reflect about x-axis. When minus comes for only x, then reflect about y-axis. Okay. In the previous case, we reflected about x-axis, no? Now in this case, you have to reflect about. In this case, you have to reflect about y-axis. You remember that. We can understand this by one example. Okay. I take y is equal to e power x. Let this be f of x. Now I want g of x as e power. In the place of x, I have to put minus x. Minus x. Yes, see. Well, f of x is equal to e power x. Basic graph. Basic graph is like this. At 1, it intersects y-axis. This is e power x graph. Now, with respect to y-axis, I want its reflection. Okay, this is the original graph. This is y is equal to e power x. Now, take the image of this with respect to y-axis. So, what is the mirror image of this part? This part will be like this, no? So, the image of this with respect to y-axis is this one. Now, take the image of this one with respect to y-axis. So, it is coming from up, no? So, this side also it should come from up. Like this. We have to connect them because this is a straight curve, no? It is a curve. So we have to give a connection for this like this. Now this is the graph of g of x is equal to e power minus x. No. Just take the image of this with respect to y-axis and draw that side, and take the image of this with respect to y-axis and draw this side. Just images. Let us take one more example. Yeah, f of x is equal to, I take same example, x square minus 4x plus 3, up open parabola. And basing on this, I have to write g of x, which is nothing but f of minus x. And if I put minus x here, that becomes x square plus 4x minus 3. Is it not? F of minus x means only x changes. This becomes like this only. And here the factors are x minus 3, x minus 1. Here the factors are x plus 3, x plus 1. Okay. By taking this basic graph, we need to draw this. Now see how to draw this. F of minus x means just take the reflection about y-axis, I said. This is origin. This is the main basic graph. Intersects x-axis at 1, 3. 1, 3. X square quotient is positive, up open parabola. And if I put x is equal to 0 here, y value will be 3. So y-intercept is 3. Graph is coming like this. This is the graph, original basic graph. Okay, only 3 things: x-intercept, y-intercept, and that's it. And the shape of the curve. Now take the reflection of this. Take the reflection of this with respect to y-axis. When intersecting at 1, 3, if you take the reflection of 1 with respect to y-axis, what is the reflection of 1 with respect to y-axis? It should be minus 1. Similarly, reflection of 3 with respect to y-axis is minus 3. Minus 3. So same diagram we are going to get like this here. Is it not? So same reflection, no, it must continue. So this is your g of x. X square plus 4x plus 3. Come on, draw this. Yeah, just appear as twins towards right axis and towards right side of y-axis, left side of y-axis. Now see type 5. If y is equal to f of x, I write a times f of x. If I multiply the original graph with a into f of x, that's y is equal to a into f of x. Then how to do this? Stretch or compress the graph. The graph about y-axis. About y-axis. Yeah, stretch means maximum will go to the maximum level and minimum will come to. This is, if you see the sine graph like this, the maximum value will go up and minimum value will come down still, right? So this is your stretch, and compression means come closer. Compression means come closer. That we have to do with respect to y-axis, and you can understand better if I take one example. So remember, when y is equal to a function, along with function some number is there, 2 or 3 like that. We can understand this better by taking one example. Let us have a look here. I take a function sin x, the basic function as sin x. Now from this I write 2 sin x, okay, and if h of x half sin x. I think now you understood what is a. When stretch we have to take and when we have to take compress. When a number is greater than 1, when a is greater than 1, okay, you stretch. So you stretch when a is greater than 1 and compress when a lies between 0 and 1. That is the meaning. So when to stretch when a is greater than 1 and when to compress when a lies between 0 and 1. And for negative already we have drawn, no? When a is negative already we have drawn for a negative f of x. Now look here. I take only single graph. Listen carefully. Let this be x-axis 0. Here I take pi by 2. You know what are the important points on x-axis to draw graph of sin x? 0, pi by 2, pi, 3 pi by 2, 2 pi. Same graph appear this side also. So I take minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. And the maximum value of sin x will be plus 1, minimum value will be minus 1. So your original graph is going to be like this. Sin 0, 0 and sin 91, sin pi 0, sin 3 pi by 2 minus 1 and sin 2 pi is again 0. This side also sin minus pi 0, sin 3 pi by 2 is plus 1 and sin minus 2 pi is 0. This is the graph of original sin x, f of x is equal to sin x. Now, when a here 2 means greater than 1. So we have to stretch the graph. We have to stretch the graph. If I take sin x value as 1 because its maximum value is 1. If I keep pi by 2 for x, sin 90 is 1 and 1 into 2 is 2. So at this point pi by 2, the maximum value it should reach to an extent of 2 now. So you have to stretch the maximum. You have to stretch the maximum. So it will look like this now. At pi by 2, it is touching the line, horizontal line, y is equal to 2. Okay. Again, if I keep pi, sin pi is 0, 2 into 0 is 0 only. So when it comes to pi, again it reaches the same point, pi. Right? When comes to this one, at 3 pi by 2, sine is minus 1. Is it not? This is minus 1. At 3 pi by 2, sine is minus 1. Okay. When I keep 3 pi by 2 here, it is minus 1. 2 into minus 1 is minus 2. So we have to stretch this again to a 1 unit, one more unit. Is that? So here minus 2. I draw a horizontal line here. Now if I stretch this to up to 2 units, right? So we are going to get like this. And when it reaches 2 pi, again 0 only. Because 2 into sine 2 pi, 2 into 0, 0. The same thing you repeat here also. At minus pi by 2, minus 1, no? You stretch this towards down. When it comes to minus pi, again it reaches minus pi. You stretch this to up. And when it comes to minus 2 pi, this. So what you understood? Whenever graph is becoming 0, it reaches 0 only. At maximum and minimum, stretch is required. You have to stretch that diagram. So this is the diagram for g of x is equal to 2 sin x. 2 sin x. Come on, draw this. I think it will take a little bit time. When a value is between 0 and 1, your half is 0.5. It is lying in between 0 and 1 only. Then we have to compress the graph. Okay, we have to compress the maximum and minimum. Compress maximum and minimum, like this, compression. Now look how we are going to draw that one. At pi by 2, you have to look at the points at maximum and minimum only. Clearly this is 2, this is 1. Your 1 half will be somewhere here. And minus half will be somewhere minus here. Right? So at half, again you draw a horizontal line. Okay? And plus half also you draw a horizontal line. So after drawing these two, then only you try to draw the third one. Otherwise you will get confused. Okay? So after finishing up these two diagrams, this one and this one, then only you will have a clear idea on drawing. Now at pi by 2, if I put pi by 2, this becomes 1 and half. So at pi by 2, this h of x value is half. Is it not? So at pi by 2, the new diagram will be here. So at 0, sine 0 is 0, 0 anything is 0 only. So at 0, when the graph is reaching 0, here also in the new graph, it remains 0 only. But the changes happen only at maximum and minimum. Okay. So instead of 1, you have to take like this at half. And when it comes to pi, it becomes 0 only. 0. Again at 3 pi by 2, it should reach minus half. Minus half. Now 2 pi 0. The same way this side. Minus half. 0. Plus half. 0. So what happened? Compression happened, no? This is the original graph. Okay. The original graph has compressed when you multiply sin x with a number less than 1. That's why we use compression will take place about y-axis. It is coming up and down means up about y-axis. So this is your h of x, half sin x. Take this also. The next one must be, if A is completely multiplied with F, then we are getting about y-axis always. But when this A occupies inside the function before x, if A comes, like f of Ax, then what must be the answer? Same thing, but about x-axis should come. In all the previous cases, we observed that one only. If A is independent of F, then a graph is about y-axis. But when A is going into the function, in the place of x, if we are writing or adding A, okay, multiplying x with A or multiplying with adding A to x, then in all the previous cases we are seeing it's about x-axis. Now I'll bring this A inside function. Then also the same thing, stretch or compress the graph about there, but x-axis will come there. That's what we are going to do then the next one. I think you finished this. In areas, these graphs, all these graphs will become useful in areas, in definite integrals, okay, in maxima and minima. If you can draw graph easily without actually solving problems by using properties, by looking at the graph itself, we can answer so many questions in calculus. That is the use of knowing graphs. And the sixth type, if y is equal to f of ax is there, ax. In our previous case, a appeared here, but now along with x, a is there. Then also stretch or compress the graph about now x-axis. So instead of stretch towards y-axis, stretch will be like this. Stretch means you have to expand like this. And compression means come closer. About x-axis means like that we have to do. Let me take the same example, sin x and g of x, h of x would become of this type, means it becomes sin 2x and here it becomes sin x by 2. Is it not? If a is greater than 1, stretch. If a is less than 1, compress. Sin x by 2. Yeah, well, you can understand this with this is a fast curve. Very fast, it will move, and it is lazy. You can understand this after looking the curve. First of all, let me draw the original graph sin x. Again, same points, and take important points: pi by 2, pi, 3 pi by 2, 2 pi, and this side minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. Okay? And the maximum value I'll keep it here, plus 1, and minimum value I'll keep it here, minus 1. Now original sin x graph, sin 0, 0, sin pi by 2 is 1, sin pi 0, sin 3 pi by 2 is minus 1, sin 2 pi will be again 0. So same graph this side, -1, -1, +1, 0. Okay. Now let us take sine 2x. Actually, stretch here. What should happen means sine 2x, no? Here compression should happen. In the place of x, if I put pi by 2, sine 2 into pi by 2, okay? If I put pi by 2 here, what happens? 2 cancel and sine pi we are getting, sine pi is 0. Sine 0 is also 0. Then where it is reaching maximum? At pi by 4. So between 0 and pi by 2, 1 pi by 4 comes, means here also I need to keep, after pi, between pi by 2 and pi we'll have 3 pi by 4. And here we'll have 5 pi by 4, 7 pi by 4. At these points, at pi by 4 it is reaching 1, means at 3 pi by 4, what is happening at 5 pi by 4? It should reach either +1 or -1 at these points, at 5 pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4, like that. So you can understand that at pi by 4 it is reaching 1. So your graph will be like this. At pi by 4, okay, pi by 4, 2 cancel, pi by 2, sin pi by 2 is 1. So at pi by 4, this graph is reaching 1. When I keep pi by 2, 2 cancel, sin pi, again it reaches 0 at pi by 2. Okay. Now, at 3 pi by 4, if I put 3 pi by 4, we are getting sin 3 pi by 2. 2 cancel, no? So it should reach -1 here. At 3 pi by 4, if I keep 3 pi by 4 here, 2 2's cancel, 3 pi by 2 we are getting for 3 pi by 4. If I substitute here. So sine of 3 pi by 2 is -1. And sin pi, sin 2 pi, if I substitute this pi here, sin 2 pi is 0. So again it should reach 0. At 5 pi by 4 it should reach maximum. And at 3 pi by 2 come to 0. And again minimum. Again at 2 pi. The same graph we are going to get like this here. At minus pi by 4, at minus pi by 4 it should be minimum. At minus pi by 2, 0. Again here it must reach maximum. Again at pi, 0. Again between these two it should reach minimum. At here it is 0. And between these two it should reach maximum. And when it comes to minus 2 pi, it comes like this. So what do you observe here? Compression about x-axis. It came like this, like this. And what is the amplitude? Amplitude means height, right? From here to here, for one curve like this, one curve like this. What is the distance you observe from here to here? 0 to pi, no? That is the distance between two consecutive. In physics you say nodes or amplitudes, you will say no. So I take one complete cycle. If you take one complete cycle from here to here, one complete cycle. So from here to here, if you measure, how much is that? It is 2 pi. In the original graph, we can say the period of this original graph is 2 pi. In the graph, how will you measure period? You see the same situation. Here it is a rising curve, no? And also it is 0. Curve value is 0. So in the rising situation, again curve reached 0. Here only it is rising now. It is in the rising situation, it reached 0 here. So what is the distance between these 2 points now? It is 2 pi. So like this we can say period of sin x is 2 pi. When it comes to sin 2x, now the sin 2x graph is this one. Now from here to here, one complete cycle is over. From here to here, what is the distance? Pi only. So for this curve, what is the period? It is pi. For this curve, period is pi. I think you understood. From the diagram, we can say it's period like that. Come on, draw this. we can say that this graph is reaching maximum fast when compared with this, is it not? So that's why we say this graph is quite faster, active. Maximum, minimum, maximum, minimum, maximum, minimum. It reaches fast. But here it has to travel some distance more. If it travels a distance of 0 to pi by 2, when it reaches pi by 2, then the graph is coming to 1. But here, when it comes to pi by 4, when x value comes to pi by 4, it is reaching 1. So a little bit faster than this. That's why we call this as fast graph or active graph. Fast. So stretch and compress become opposite when you compare with the previous graph. Here compression took place now. So here when your a value is greater than 1, compression takes place, and when a value lies between 0 and 1, stretch takes place with respect to x-axis. Here you observe that. Now let us see this one, sin x by 2. Sin x by 2. When, for what value of x this becomes 1? Pi. When x is pi, sin pi by 2 becomes 1. So at this position, the new graph is reaching 1. Is it not? Shall I draw a graph here itself, or shall we take one more graph? Chandana.
Sir, one more graph, sir.
One more graph you require. Okay. So for sin x by 2, we draw one more graph. Zero, pi by 2, pi, 3 pi by 2, 2 pi, and it is minus pi by 2, minus pi, minus 3 pi by 2. Maximum value plus 1, minimum value is minus 1, and original sin x graph will be at pi by 2 it should reach 1, and pi 0, 3 pi by 2 is minus 1, and 2 pi is 0 again. Minus pi by 2 is minus 1, minus pi 0, 3 pi minus 3 pi by 2 is plus 1, and minus 2 pi 0 again. This is the original graph. Okay. Now this one. If I keep x is equal to pi, then sin pi by 2 is 1. Here, sin graph is reaching 1. So sin 0 is 0 only. Sin 0 by 2 is 0 only. So our new graph is like this now. Okay. When I keep 3 pi by 2 here, when I keep 2 pi here, 2 pi, it is 0, no? 2 pi means 2 to cancel, sin pi 0 again. Like this. Similar graph this side. At pi, it is maximum. At minus pi, it should be minimum. And 2 pi 0 again. So what happened? Stretched. If we stretch this, if we stretch the original graph, we are getting this. It's not. So this is the graph of sin x by 2. This is h of x now. H of x is sin x by 2. Come and draw this now. The period of sin x from diagram, I said, if you take the diagram from 0 onwards, this is one complete cycle. Okay, don't say this from here to here. The position of this point and this position of this point are same. The position of this point is on the curve when it is rising, when the curve is rising. But here the curve is decreasing. How can you say that the position of this point and this point are same? Value may be same, but position is not same. We say the same phase. 2 points are said to be in same phase. Same phase means situation also must be like that only. But here these 2 points are not in same phase. These 2 points, this point and this point, are said to be in same phase, because here on the increasing curve we have taken a point on x-axis. The same situation occurs again here. It is increasing, the curve is increasing. Okay, now the situation is same here. Now take the difference of these 2 points. It is 2 pi. That phase difference is called period of this function. That is the period. And this is called amplitude. From here to here, height is there, no? That is amplitude. Here amplitude does not change. Only period is changing. And for this, what is the period? For this graph, period is 2 pi. Is it not? From here, is it 2 pi or 4 pi? Same phase you have to see. This is increasing, this is decreasing. So you have to look here, from here to here, 4 pi. Yeah, I hope you understood. It is 9:30. Yeah, I'll ask you whether you understood or not.